Happy Friday, everybody. Alas, I'm not in school today. I'm in Cambodia at a Cambodian school. I'm working with math teachers over there. So because I'm not in class today, I made another video. So hopefully this will help you learn the next stage of factoring. And you'll go through these notes, practice with some problems, and hopefully finish your homework so you can go away for the weekend and review or just enjoy a relaxing weekend. I will give you a quiz next class, so be prepared to have a quiz. It's Friday. You'll have day B, or is it day B? Yeah, day B on Monday. Deepavali is Tuesday, so your quiz will be next week, Wednesday. Okay? So if you have questions, maybe try to drop in and see me on Monday during lunch or during morning break. All right, lesson 5, the difference of squares. So we've kind of seen this before, but now as you're getting better at factoring, I hope you can pick up some of these shortcuts. You don't need to make a box every single time with what we did last class, but maybe you still do, and that's okay. You need to go with whatever is your strength, whatever's easiest for you to guarantee your correct answers. So let's review what a perfect square is. A perfect square is the product of a number times itself. So it's the result of when you multiply a number times itself. So name some perfect squares. Okay, well 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 25 is a perfect square, 36. How am I getting these? Well, a number times itself. So 1 times 1, that's 1. What's the next number in order? 2. 2 times 2 is 4. Therefore, the result, or this product, remember, the perfect square is the actual product. So these numbers in red are the perfect squares. The blue is how I'm getting that perfect square. So 3 times 3, that's 9. So 9 is the perfect square. 4 times 4, that's 16. So 16 is the perfect square. 5 times 5 is 25. 6 times 6, 36. Okay, how about x squared? Is that a perfect square? Is there some number times itself? Sure, but it's an unknown number. X times x is x squared. So x squared is a perfect square. If you continue, you should go ahead and continue all these numbers through 12 or 13, 14, 15. So 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11, 121. These are all the perfect squares here. 13 times 13, is that 12 times 12, sorry, is 144. So 10 squared, 11 squared, 12 squared. 13 squared is 169, 14 squared is 196, 15 squared, 225. Right, so if you have a calculator, you could have done that on the calculator, or if you ever forget. Right, but here are the perfect squares all the way through 15. Why am I writing them out? Because these are what you're going to see through all these factoring problems. Okay, so let's use this information to factor these perfect square binomials. Remember binomials, that means 2 terms. And each of these terms is a perfect square. A squared, that's a perfect square. 1, that's a perfect square. The minus sign doesn't have anything to do with that perfect square. But you do have to have the difference of squares, which means the difference indicates the minus sign there. So what do we know? We know that this a squared goes in the upper left-hand box. We know the minus 1 goes in the lower right box. Well, a squared is a perfect square. We get a times a. 1 is a perfect square. We can only multiply 1 times 1 to get 1. Well, if we are going to add, so remember if we did our x, we would multiply to get a -1, but add to get a 0. So what two numbers multiply to give me -1, but add to give me 0? Well, it has to be a +1 and a -1. Positive times negative is negative. +1 plus -1 is 0. So one of these ones needs to be a positive, and one of these ones needs to be a negative. How did I know that? Because when you multiply the row times the column, I need to get this result. So a +1 times -1 would give me this -1 right here. Okay, so then what would go here? We would have a times +1, which is +1a, a times -1, which is -1a, and when we add these up, they cancel and give us this 0. That's not there. So what are my factors? My factors are a plus 1 times a minus 1. We'll come back to that. Okay, 9b squared minus 4. Again, it's a binomial. There's only 2 terms. They're separated by a minus sign. Each term is a perfect square. 9, that's 3 times 3. B squared, that's b times b. 4, that's 2 times 2. So we put this 9b squared in the upper left. We put this -4 in the lower right. So now this is a perfect square. So what times what will give us 9b squared? Well, 9 is a perfect square, so that's 3 times 3. And then b is a perfect square, so that's b times b. Right? A perfect square is when you have the same thing multiplied by itself to get the product in the end. So we would have 3b times 3b. What two numbers multiply to give us 4? Well, that's 2 times 2. But once again, we need to multiply to get a -4. So what needs to be true about one of these 2's? One of the 2's needs to be positive, and the other 2 needs to be negative, because a -2 times a +2 will give us -4. If we filled in this box, 3b times +2 is +6b. 3b times -2 is -6b. And when we add these together, what happens when we add -6b plus +6b? The b's cancel, which is why we don't have a b term up here. We just have this first term of 9b squared and the second term of -4. So here is my answer, 3b plus 2 times 3b minus 2. Okay, so let's look at these. The question here is, do you see a pattern? So what is your pattern? Look at the factors of a squared minus 1. It was a times a, that gives you a squared. +1 times -1 gives us -1. Your inside and outside terms, these terms right here, cancel. These parentheses are almost identical, except one has a plus sign separating the two terms, and the other has a minus sign. Right? Do you see that? So identical parentheses except one has a plus sign, one has a minus sign. Okay, let's look at these answers. Identical parentheses except one has a plus sign, one has a minus sign. So that is called the difference of squares. Why is it called the difference of squares? Because minus here means difference. We're taking the difference between two perfect squares. So notice the title, the difference of squares. So let's do some more. If you're picking it up, then you should pause and do these problems on your own. If you want to still watch and see what I do, then you can go ahead and follow along. We have a perfect square. X times x is x squared. We have a perfect square in 9. 3 times 3 is 9. So we just saw in our pattern that our parentheses are going to be identical, except one parentheses is going to have a plus sign, one parentheses is going to have a minus sign. A times a gives us the a squared. +1 times -1 gives us -1. So in this case, we have x times x gives us x squared. And we have positive 3 times negative 3 gives us negative 9. Our parentheses are almost identical, except one has a plus sign and one has a minus sign. Right? If you want to check it, you can do a quick check. X plus 3, x minus 3. This is for you, Abby. You're checking it. X times x is x squared. X times positive 3 is positive 3x. X times negative 3 is negative 3x. Negative 3 times positive 3 is negative 9. When you write it out, the 3x and negative 3x cancel, leaving us with x squared minus 9. Is that my original? Yes, it is. Therefore, I know this is my answer. So go straight to your two parentheses. What times what will give me d squared? So what times what will give me d squared? Well, it has to be d times d. What times what will give me negative 121? Well, it's positive 11 and negative 11. So that's my final answer. I can FOIL it, check it, but that positive 11d and negative 11d are going to cancel out. So that's your final answer. Okay, make our two parentheses. What times what will give us 100h squared? Well, that's 10 times 10 to give us the 100, and h times h to give us the h squared. So I get 10h times 10h. What times what will give me negative 81? Well, that's plus 9 and minus 9. And there you have it. Again, if you catch on now, pause. Go ahead and pause and try to do the rest on your own, and then come back and check with me if you want. But I'm going to continue. 25k squared. You should get 5k times 5k. 5 times 5 is 25. K times k is k squared. Negative 64j squared. Well, we have to have a plus and a minus, because positive times negative is negative. And then 8 times 8 is 64, but notice it has a j squared attached to it. That's okay, we just have to include a j with each one. Positive 8j times negative 8j gives me negative 64j squared. Okay, moving on. What two numbers multiply to give us 4z squared? Well, 2 times 2 is 4. Z times z is z squared. What two numbers multiply to give us negative 9a squared? Well, it has to be plus and minus. 3 times 3 is 9, and a times a is a squared. Okay, let's look at this one. What times what will give me 6x squared? Okay, well, let's look at this. Is 6 a perfect square? So is 6 a perfect square? Can we multiply some number times itself to give us 6? 1 times 6, well, that's not the same number. 2 times 3, that's not the same number. So no, 6 is not a perfect square. So can I break it up into this? No, I cannot. Is 7 a perfect square? No, it's not. So there's nothing we can do on this one. So we call this prime. Okay, the next one. Well, we have a perfect square here, right? It's 4a squared. 2a times 2a gives me 4a squared. And then 25b squared, but it's a positive here. So that looks like we should do positive 5b and positive 5b. The problem is this doesn't work. If we did a quick check, we would do 2a plus 5b, 2a plus 5b. Well, this is 4a squared, this is 25b squared, so that works. But these two are 10ab, and this is 10ab, And they're both positive, so they don't cancel.